that's stable, has a low rate of wear and tear. So it only undergoes mitosis generally after injury. Rarely undergoes mitosis. Examples of stable epithelium, epithelial tissues that only have to undergo fixing when they're injured, and it isn't very often. The kidneys, tubules, they're all tubes. Liver, the liver is all epithelial cells in tubes, okay? Pancreas, many glands. All the glands in your body, your salivary glands, your reproductive glands, your digestive glands, they're all tubes of epithelial tissue that make particular enzymes, digestive aids, and hormones. But they don't get injured a lot, so they only undergo mitosis when they need to fix themselves. So if you have an injured liver and they can stop you from bleeding to death, you can actually regenerate your liver. Now the downside of this is that if you do injure them a lot, like for example in pancreatic cancer, if you drink a lot, that injures the liver and the pancreas, they can become cancerous, and that can be really bad. But generally, they have very low rates of mitosis, so they're not the first players to become cancerous. On the other hand, labile epithelium, like the top layer of skin, okay, called the epidermis, is what we call labile epithelium. It constantly gets rubbed, turns over at the rate of every 20 days you make a whole new top layer of your skin. You make a whole new epidermis. And that undergoes such rapid regeneration and repair that it's very commonly cancerous. The most common cancer is skin cancer, because that top layer of skin, called epidermis, made up of epidermal cells, just constantly getting abraded and traumatized, mostly by the sun. I should put some pictures in here in order. How about some surface specializations? The surface of the cell is often specialized. So this is a long row of tube-shaped epithelial cells. They're in your intestines. I can see the suggestion of a basement membrane right down here. Here's the air, right up here, okay? You see this fuzzy stuff here? These epithelial cells are specialized to absorb nutrients. So when cells have a particular job to do, their surfaces often grow specialized growth. In epithelial cells, all the cells right next to each other. There's the basement membrane right down here. And the surface is convoluted to make a structure called microvilli. LLI, I think it's 2 L's. So the surface is folded up and down and up and down and up and down. And that gives a brushy appearance to the surface. So sometimes we call this a brush border. See that fuzz right there? Now, when an intestinal cell, intestinal lining cells have this beautiful healthy brush border, it means they have enough surface area that they beautifully absorb nutrients. And that's what you want. You want a cell, a surface cell now that really absorbs vitamins and nutrients from your digestive tract really well. So all the surface cells, when they're healthy, will have this brush border to increase the surface area for absorption 1,000-fold. Okay? When you get intestinal infections, parasitic infections, or chronic inflammation like you might with Crohn's disease or some food allergies, you can actually lose this brush border and it's completely gone. So now that whole brush border is gone. The surface of the cells is smooth and they just don't have the surface area to pick up nutrients like they did in the past. And then you become terribly malnourished. Your epithelial cells just can't absorb vitamins like they did before. It's also possible in some epithelial cells that the job might be not to absorb nutrients, and so 3 epithelial cells, long ones. Here they are with their basement membrane. Here's the air up here. And now their job is not to absorb nutrients, but to move materials along, to push materials along. In this case, they may have structures like flagella. You know how there are microscopic organisms that have a tail for swimming? In fact, the animal sperm has a flagella for swimming. There are epithelial cells that have flagella on them. Now they're glued to one another so they can't swim away, but their job is to move a substance along, to beat it along and move it along. As we'll learn very soon, your airway is filled with these epithelial cells and they move along a thin carpet of mucus whose job it is to trap wastes in the air. So whenever you breathe pollution in, it's trapped by this little carpet of mucus, and then the cilia on the cells beat forward, always uphill, to move this waste material out of your lungs until eventually that waste mucus is beat all the way up to almost into the mouth, where it's swallowed every time you swallow. Now, it's not noticeable under normal circumstances that you're swallowing that mucus carpet because there's so little, right? But if you get a cold, right, then you make a lot more mucus to trap all that cold virus, and then you notice all that phlegm that you're coughing out. Yes, there's a lot of phlegm and mucus in this. So epithelial cells may be designed to move things along. Yeah.
Can you briefly go over the cilia role again?
So the job of cilia is to actually, they're very long and they move rapidly back and forth. So they either move themselves, if they're free cells, they can make themselves swim, or if they're stuck together, they're going to move things along in the passageway. Let me give you a better example. When the egg is ovulated out of the ovary and goes into the tubes or the oviducts, how do you think it moves along? The lining of the oviduct has these little, and it squeezes and moves, and it just brushes these little eggs and moves them down.
So how is that any different than the role of the flagella?
It's not.
It's not.
They're flagella.
It's the same.
We
Okay,
haven't
different
forgotten.
name.
We still do it.
Got it, okay.
But people don't like to think of them having cells that are swimming around, but we do. You know, we do have some categories of cells that still move around by means of a flagella, and it's the same flagella used by protists like Euglena and Paramecium. Yeah.
Aren't flagellas typically a little bit bigger than cilia?
Yeah,
Okay.
they are, because the cilia don't move, they're just surface ripples.
Right.
Flagella are really, really
Okay.
long, and they create this, here they are. Here they are in the airway. You can see how long they are. And they really do, the cell spends a lot of energy moving them, waving them back and forth. So they actively move things along.
So cilia